we're going to review a little bit first just how to solve by graphing an inequality. So let's review. It's in slope-intercept form. What's my slope? And what's my y-intercept? -1. Okay, so I go to -1. This says up and right, up to right 3 or down to left 3. So I go up to 1, 2, 3, or I go down to 1, 2, 3. Before I draw my line, I have to decide if it's a solid or dashed line. What kind of line is it? Dash, why is that a shot? It's not an equal to. So what does that mean, that these are dashed? Are they part of my solution, these points? No. The dash line, it's like when we had an open circle, right? When you do the x less than 3 or 0, right? It says don't include this one, so we're not including the points on this line. Now y is less than this value, so let's see, above or below? Below, where's above? Yeah. Right. So these, so what does that mean? It means that all the points on here will be solutions. So if I give you points, -1, 4, is -1, 4 a solution to this inequality? Well, how do I know? I go to -1, 1, 2, 3, what's up here? Is it a solution? No, it's not in the shaded area. How about 5, -3? 1, 2, 3, 4, 5, 1, 2, 3. Oh, yes. Yes. So if I'm in the shaded part, I am a solution. If I'm not, then I'm not. That's what this is trying to tell me. Oh, cool. How do you graph this thing? What does that look like, sir? Yes. Horizontal, right? They're all straight lines. Well, let's think of it this way. Great, that's right. So what's the slope of this line? Just looking at it. Well, hang on a second. Comparing it to y equals mx plus b, what's it? Where's the x? It's gone. What must m have been? 0. And what's my b? So 1, 2, 3. And what does a line with a 0 slope look like? But they're all kind of a 0 line. Horizontal. Thank you. Horizontal line. And solid or dash? Solid, because this, right? If you pick an x, a y on here, it's 3. Is 3 bigger than or -3? -3 bigger than or equal to -3? Yes, because it's equal. Now, where are they bigger? On top above. Right? Aren't all the y's up here bigger than -3? Yes. How about this guy? What does that look like, sir? Yes.
You go to 1.
Not 1.
And then move along.
Vertical line. Solid or dash? Dash line. Because is this part of my solution? Is 1 bigger than 1? No. So the points on this line are not part of the solution. Again, I do like putting just a little. Sometimes it is hard to tell. Now, where are the x's bigger than 1? Well, the top is kind of hard to say because I've got this vertical line. So left or so right here's 1. This one's 2. That one's 3. Where are the x's bigger than 1? This way. This way. Okay. So knowing these two things are going to become pretty important because we're going to be looking at systems of inequalities. And to do that, we're going to look at a word problem. Anybody ever have to write a lab report before? Today's, the science teachers make you do that? So, this particular science teacher, some pages are illustrations and some pages are just writing. So you can have no more than 12 pages. So if I'm using x and y, and I'm going to let x be the illustrated pages, how many we have? The number of illustrated pages. I'm going to let y be the number of written pages that I have. I want to write some inequalities. So here's my first one. X plus y less than or equal to 12. So where did that come from? Total, right? It says you have to write a lab report no more than 12 pages. Well, if I have two different kinds of pages, if I add them together, they can't be more than 12. So less than or equal to 12. How about this one? X less than or equal to 8. Where's that coming from? I can only have as many as 8 illustrated pages. So what's my final inequality going to be? Yeah, what's it going to be?
Like x is
Well, I could have 84. Maybe I could have 2 and 3. Or I can have 81. Right? There's all different kinds. How do I represent what all the different possibilities are? So that's what we're going to be looking at. So before we do that, let's just look at a little bit of vocabulary. A system of linear inequalities in 2 variables. Now we did this when we talked about equations. Remember what those look like? You can have 3x plus 4y equals 10 and negative 2x plus 3y. Right? This is a system of equations. What are inequalities? Now they're going to be inequalities. But again, the x's and y's match. They're the same thing. So maybe this becomes a greater than, and maybe this is a less than. But they look the same. What is a solution? A solution is an xy pair, just like they were for an equation. But I can have more than one of them. I can have a lot more than one of them. And what is a graph of a system of linear inequalities? It shows all the solutions to this system of inequalities. So, Thomas Chief, let's do an example here. Oh, that's really graph the inequality with shading, right? Because that's how you graph an inequality. And then what you're going to do is you're going to look for where these shaded areas intersect. Okay, now let's do one. This one's on your paper here. It's example 1. Where this is a system of inequality because I have more than one of them. And I want to know where the solutions are. So I'm going to graph each one. So fortunately, they're both slope-intercept form. So what's the slope of the first one? And what's the y-intercept? Okay. So y-intercept is 2. This is an up 1, right 2, or a down 1, left 2. So up 1, right 2, down 1, left 2. If I can see the line, is it going to be a solid or dashed line? Dashed line because of a less than. Right? These points are not part of the solution to this inequality. And I'm just putting a little note that it's dashed, but this can get a little messy. Now, am I going to shade above or below for this guy? Below. Now, very, very lightly, you are doing this very lightly on your paper. A little hard for me to do it lightly up here the way this pen works, but very, and don't be doing this. Anybody who's doing this, stop it. I want these kinds of lines. Okay? Don't be doing this. Don't be coloring in. Don't do it. Just very light. I just want to know where am I shading. And you'll see why in a minute. If you don't do this, it becomes a lot harder. Okay, I'm going to change my color. If you have colored pencils, you can do this too. Here's my M. My slope is negative 2. Right? Y-intercept is 5. I'm going to go graph that guy. This is a down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Okay, I see it now. Is it going to be a solid or dashed line? Solid line. Whoops. We're up close here. There we go. And again, I like putting my little note here so I can see what I'm doing. Greater than. Am I going to be shading above or below? Okay, lightly, and just make lines. Don't do colored in there. Very, very lightly. Because what am I looking for now? I am looking for the place where the shading intersects. So it's this area in here. And if you have a highlighter, this is a really good use for it. If you don't have a highlighter, you're dark. Now you're doing this with the pencil. You want that to be nice and dark. So what did I just shade? The places that got shaded with both lines. Is there a question? I think I saw a question. Yeah. So notice that I shaded below, so that includes this area, right? And then I shaded to the right. So where are they both in common? Yeah. Right? Yeah, that makes sense? Yeah. Well, I made it a fraction, negative 2 over 1, so I knew how to go right. Down to right. You start at 5, and you're going to go down to right. Down to right. What does the graph mean? Alright, now what did I just graph here? This is the solution to both. It's the x and y pairs that will work in both. Yeah. Well, we're just graphing them. It's a little bit hard to write, so we're just going to do graphing. So for the inequalities, we're only doing the graphing method. Want to hear all right? We're not worrying about this. You can't quantify something difficult. I guess this is how you quantify it. You say this. Now, how do I know I'm kind of in the right region? Jerry? Say it again?
The difference between a system and linear inequalities.
And what? The difference between a system with linear inequalities and all three of these don't make sense to you? This one?
It's a difference. It's saying
This one?
all of them
This one?
are different.
These two.
All of them.
All right, this one just says, oh, wait, you got a question. This just says, what is it? It's when you have two or more inequalities, linear inequalities, working together in some way. This says, how do I know if something is a solution to a system? It's if you plug it into all of them, the xy pairs, they're all going to be true inequalities. That's a solution. And there's many solutions. The graph of the system is this thing, which shows all the solutions. And you know where they are? Right here. If you pick a point in here, it's going to work in both of them. It is a solution to them. So the equations only had one solution. How many solutions do inequality systems have? Infinite number, right? Everything in this region. So, 2, 2. I don't even like that one. I'm going to pick a better one. How about 5, 3? Is that a solution? 1, 2, 3, 4, 5, 1, 2. It looks like it.
Yeah.
Now, you can kind of test it. I picked the right region by plugging it in here. And I'm going to change it now to 4, 3. Why am I doing that? Because I'm seeing what I have to plug in. 1, 2, 3, 4. So I'm going to test this point. So I'm just going to plug in the x's and the y's. So 3 less than half 4. I don't know, did I answer your question, Jerry? So 3 less than half of 4 is 2 plus 2. Is 3 less than 4? Okay, so what's in this one? Let me try this one. Is 3 bigger than negative 2 times 4 plus 5? Is 3 bigger than negative 8 plus 5? Is 3 bigger than negative 3? That's right. So this point, in the region where I think it is, works. It's just a way to test the region, because sometimes we get, we shake it the wrong way, we don't get the right region. Yeah. You don't have to, because I just put it here because it was here. But you don't really have to, because we're not testing the equal. You're right, we're only testing the infinite. You're absolutely right. But that's basically it. So this is what would be dark. This part very light while we're trying to figure it out. Ooh, this is a good one. We have time for it. So let's graph all three. All three? Yes, all three. What is y less than or equal to 5? What does y equal to 5 look like? Yeah, horizontal goes through 5 solid? Yeah. Because I've got the equal. And now shading lightly. Less than is below, right? So you're shading very lightly. It's very hard for me to go light here. But you can with your pencil. And you're just making the lines. You're not making a whole big coloring thing. Let's look for, what other color? I'll try this one. X less than 4. Well, 1, 2, 3, 4. Remember, that's my vertical. Why am I making dash lines? Yeah, right? This is not part of the solution. Less than 4, that's this way. So far, can we see the region that we have? Sort of. Right? It's kind of this box right here. It's not up here, right? Because I can't be bigger than 5. And now I want to do that last little bit. M is negative 2. And B is 2. So there's 2. Down 2, right 1. Down 2, right 1. Down 2, right 1. Up 2, left 1. Solid or dashed? Solid. Am I shading above or below this line? Which is up here, right? Now we're starting to see, and this is the hard part, is where is the point of intersection? Like the top. Right here. Right? I shaded in all 3 places right here. This is the region we're talking about. If you were to pick any xy pair in here, it would make all these. Let's pick one. I'm going to pick, what do I want to say here? I'm going to do 3, 0. I don't like 2, 0. So is 0 less than or equal to 5, right? Because my y is 0. Is that true? Yeah. Is x is 3, is that less than 4? Yeah. Let's try this one. Is 0 bigger than negative 2 times 3 plus 2? let's see, that's negative 6 plus 2. Is 0 bigger than or equal to negative 4? Yes. I'm in a good region. It's a nice way to just test that you picked the right region, because it's good and you can get confusing. All right, when we come back, I'd like you to work on these sides, and we'll continue our Andrew. Okay, so when we started, we had to do the lab report. It can't be more than 12 pages, no more than 8 pages of illustrations, and no more than 4 written pages. So these are our inequalities. So let's see if we can graph this. So let's see. This one I have to put into mx plus b form. So y less than negative x plus 12. So let's see, I guess I'm going to have to do this. We do it by twos. I think I'm still going to be up to things a little bit. I don't think I have this on your paper if you're looking for it, so if you're taking a note, you can do this on your own. So let's see, so I'm going to put one here, and then negative x, right? Going this way. And then, now why am I drawing a solid line, first of all? How come I don't have arrows?
I know, because it's only
Yeah, well, because, but these are pages, right? These are numbers of pages, right? So can you have negative? Not really, right? It doesn't make sense. So it doesn't make sense to really go out of quadrant 1 here, so I'm not going to. X less than or equal to 8. So again, I'll try a different color. Oh, less than, right this way. Gotta do my shading. Then I'm going to look at x less than or equal to 8. 2, 4, 6, 8, right? So that's my line going this way, solid line, right? Oops. But again, I don't really need to go past here. So less than, right? That's this direction. And then I want new color. Y less than or equal to 4. That's here. Again, solid line. So where are my possibilities? Oops, I don't like this one. And here, right? So what are my possible arrangements that I could have? Well, I could have 2 and 0. I could have over here, what's going on here, that's 4 and 2. Right? So all different possible combinations, and this shows what they all are in this area. Again, because these are real life situations, I only want kind of integer values, even though I am showing all of them. We're probably not going to have 2.5 pages. That probably isn't what it's meant by that. But we can use this to kind of, figure out inequality type situations. All right, now we're on to new tries. Should we do the first one just to remind us how to do it, or are we okay? You ready to go fly solo?
Yeah.
No.
Good to know. If you're ready to fly solo, go ahead. Those of you who just want to see one more example, let's do that. So again, we're going to graph these 2 lines, and you can go ahead if you feel like you can. You don't have to stay with me here. I am going to count by 2s because these graphs are a little small. Just so I can fit this stuff in here. So this one, B is negative 7. That's like here. I'm going to go up 3, right 1. That's 3. Right 1. 3. That's hard to do with weird scales. But I can kind of see what's happening here. So it's a dashed line, and why is it a dashed line? Not equal to. Not equal to. So, and I want to be greater than? That's above. And let's see about the other one now. 2x plus 1. So there's my b of 1. This says go down to right 3. Down to right 3. Oh, I'm having a hard time with this. Or up to this way. And this one's going to be a solid line. And it's less than infinite. So where is my overlap space? It's like down in here. This should be what you've got. Okay. So see if you can try the other ones. See if you can do those on your own. Yeah. So yes, you're right. I zigged when I should have zagged. So let me try to fix this guy. Like this one won't be here. What? What? Right? Isn't that better? For that one? Because I went down to right 3, I should have gone up 2.
Yeah, something like that.
Is that what you did? Yeah. It's perfect, gonna try this one, see if I don't make a mistake. X has to be bigger than negative 2. I know x equals negative 2 is the vertical line, right? So that's here. Whoops. And I want it to be dashed. Is anybody kind of labeling these? Because that's how confusing it gets. It's hard to tell. Now x is bigger, right? So I'm going this way. Y has to be greater than negative 3. This one. 1, 2, 3. And that's also dashed. And so when I'm drawing this, notice how I didn't even go over here? Because I already know that's not going to be in the solution, so I didn't even shade there. I shaded where I could see the solution. Sometimes that makes it a little bit easier too. And now I got to do this, whoops, this way. So let's see, y-intercept is 2. And the slope is up 3, right 5. 1, 2, 3, 1, 2, 3, 4, 5. Or down 3, 1, 2, 3. Left 5, 2, 3, 5. That's going to be a solid line. And this one's a less than, right? Okay, so where is that? Okay. This match what you guys are getting?
Yeah. Yes.
What? Does it? No?
What?
I could have made a mistake in there. Possible.
No, look at that one. Which one are you? No.
Anybody with me? You guys are only low. Alright, this is for you. So y is greater than 2. A dash line is greater than, right? Oh, I'm going to have a problem with this. You know what I'm going to do now? If you're the only one listening.
I am.
Is I'm going to do this one by 2.
I'm not. I did that with my tuition. That's what I did. Yeah.
Okay, so if I'm bigger than 2, that's over here. And then y less than 8, well this is 8. Also a dash line. So far I'm just in this little piece here. Now y has to be greater than 4x minus 1. Oh, that's a little better. So I go to negative 1. Up 4, 1, 2, 3, 4, right 1. Or down 4. Left 1. This one's going to be a solid line. And it's greater than above. So that's this way. So it looks like, here's my stool. Well, okay. This stool. What do you guys think?
Yeah, that's right.
What were you going on? We're going to sort of like, oh, no, is it right?
Yeah.
Yeah. So again, let's remind ourselves what this means. Is the point negative 4, 6 a solution to this linear system? How can I tell? Negative 2, negative 4, right? 2, 4, 6. So is it a solution?
I did that, but I don't know if it's
Yes.
put the line negative equal.
Okay, so these points in the shaded region satisfy all 3 of the inequalities of the first type. Any questions? Quick review. Systems of linear equalities are 2 or more linear inequalities in the same variable. You graph them by finding the intersection of the half plane of the solutions of all those inequalities, and you just graph. You shade, find the intersection. Any last questions? No. What?
Are we working